In section 2.8, we talk about absolute value inequalities. So for less than, I have an easy way to remember it because this becomes a less than inequality. So the solutions of an inequality of the form absolute value of ax plus b is less than c, where a is not equal to 0 and c is a positive number, are those values that satisfy ax plus b is less than c and ax plus b is greater than negative c. So we flipped the sign and made the c negative, and we also just had the regular inequality without the absolute value bars. We can also write this as a compound inequality, as negative c is less than ax plus b, which is less than c. We also have a greater than inequality, and you can remember greater than. And the solutions of an inequality of the form ax plus b is greater than c, where a is not equal to 0 and c is a positive number, are those values that satisfy ax plus b is greater than c, or ax plus b is less than negative c. And so we want to solve and graph the solution. We have x, the absolute value of x minus 2/3 is less than or equal to 5/2. And so this is going to be a less than problem because we have the absolute value by itself on the left-hand side, and we have a less than symbol. So this is a less than problem. And so how we can write it is we're going to put negative 5/2 is less than or equal to, we drop the absolute value bars and just write x minus 2/3, and then is less than or equal to 5/2. And so this method is nice because we can just do all of the computation at one time. So we need to get rid of our denominators, and so my LCD is going to be 6. So we want to multiply everything by 6. And so now we can simplify. 2 goes into 6 3 times. 3 goes into 6 twice. And 2 goes into 6 3 times. And so what we end up with is 3 times negative 5, which is negative 15, is less than or equal to 6x minus 2 times 2, which is 4, which is less than or equal to 3 times 5, which is 15. And so now we just want to get the x in between the inequality symbols by itself. So we're going to add 4 to both sides. And so we cancel in the middle. Negative 15 plus 4 is going to give me negative 11 is less than or equal to 6x, which is less than or equal to 19. And so the last thing I can do is I can divide everything by 6. And so it ends up canceling in the middle. And we are left with negative 11 over 6 is less than or equal to x, which is less than or equal to 19 over 6. And so where we're going to shade is in between those two endpoints, negative 11 over 6 and 19 over 6. And just so we know, negative 11 over 6 is about negative 1.83, and 19 over 6 is about 3.167. And we're just putting that down so we can actually plot the values. So we're going to have a closed dot at negative 1.83, which is going to be really close to the negative 2, but not quite. And we're going to have a closed dot a little bit past 3. And all we do is, because our x is in between those two values, that is where we are going to shade. Let's try another one. We have the absolute value of 2 times x minus 1 plus 4 is less than 8. So my absolute value is by itself on the left-hand side, which is good. And that means that this is going to be a less than problem again. And so we're just going to do the same thing as we did in the first example. We're going to put negative 8 on the left-hand side. We're going to drop the absolute value and just put 2 times x minus 1 plus 4, and that's less than 8. So we want to make sure that we distribute the 2 to both pieces. We've got negative 8 is less than 2x minus 2 plus 4, which is less than 8. And so we have some like terms we can combine in the middle before we start solving for x. Negative 8 is less than 2x plus 2, which is less than 8. And so the first step is we want to subtract 2 from all sides. And so in the middle, it's going to cancel. We get negative 10 is less than 2x, which is less than 6. And the last thing we can do is we can divide everything by 2. And so they end up canceling in the middle, and we get negative 5 is less than x, which is less than 3. And so we're going to have an open dot on negative 5 and on 3. And we just want to shade in between. And so let's just go ahead and fill in the information for these boxes so we can complete the rest of the examples. So the solutions of an inequality of the form absolute value of ax plus b is less than c, where a is not equal to 0 and c is a positive number, are those values that satisfy. We've got those two different conditions. Ax plus b is less than c, and ax plus b is greater than negative c, but we can also write it the shorthand way as negative c is less than ax plus b, which is less than c. Same definition as above, I just want to bring it down so we can look at it if we need to. What about for greater than? If we have the absolute value of ax plus b is greater than c, where a is not equal to 0 and c is a positive number, then we have our two options. We've got ax plus b is greater than c, or ax plus b is less than negative c. And so let's go ahead and look at example number 3 now. We have the absolute value of negative 3x plus 6 is greater than 18. So this is going to be a greater than problem. And so we're going to have two different equations or inequalities going on here. We've got negative 3x plus 6 is greater than 18, or we've got negative 3x plus 6 is less than negative 18. And we just need to solve. So we are going to subtract 6, and we can do this on both equations actually. It's going to be the first step for both. And so on the left-hand side, the 6's cancel. And we end up with negative 3x is greater than 12. Or we've got negative 3x is less than negative 24. And so the last step we can do is divide by negative 3. And so it ends up canceling on the left-hand side. And because we're dividing by a negative number, we need to flip the sign. So we get x is less than negative 4, or we end up with x is greater than positive 8. And so let's go ahead and write our numbers down. I'm going to go by 2's because we have a positive 8 and a negative 4. So negative 6, negative 4, negative 2, 0, 2, 4, 6, 8, 10, 12, and 14. So we are going to have an open dot on 8. And we are going to have an open dot on negative 4. Now because it's x is less than negative 4, we are going to shade to the left-hand side. And because x is greater than 8, then we shade to the right-hand side. And because it's an inequality, an OR inequality, then we take everything that's shaded as an answer. And for the last one, we have the absolute value of 3 minus 2/3 x is greater than or equal to 5. So again, the absolute value is completely by itself, which is good. And we have a greater than symbol, which means this is going to be another OR inequality. And so let's set up our two inequalities. We have 3 minus 2/3 x is greater than or equal to 5, or we have 3 minus 2/3 x is less than or equal to negative 5. And so let's go ahead and just get rid of our denominator. And our denominator, or LCD, is going to be 3. So we need to multiply everything by 3. And we're going to do the same thing for the second one. So in both situations, the denominator is going to cancel with the 3. And so now we are only going to be working with a nice inequality with no more fractions. We've got 3 times 3, which is going to give me 9, minus 2x, which is greater than or equal to 15. Or we've got 9 minus 2x is less than or equal to negative 15. And so let's go ahead and we are going to subtract 9 from both sides. And we can do this in both scenarios. And so it ends up canceling on the left. We have negative 2x is greater than or equal to 6. Or we've got negative 2x is less than or equal to negative 24. And so the last thing I can do is I can divide by negative 2. And again, the negative 2's are going to cancel, but I did divide by a negative number, so this now becomes x is less than or equal to negative 3. Or we get x is greater than or equal to 12. And so we need to plot this and write out our numbers. So again, I'm going to go by 2's. Negative 4, negative 2, 0, 2, 4, 6, 8, 10, 12, 14, 16. We will have a closed dot on 12. And we are going to shade to the right-hand side. And we will have a closed dot on negative 3, so between the negative 2 and negative 4. And we shade to the left. And because it's an OR compound inequality, that just means that we are going to take everything that's shaded as a solution.